Good afternoon, my YouTube viewers. In this particular video, what we're going to talk about is we're going to talk about some more experimental design, and we're going to talk about how experimental design can work with biodiversity. And so we have a practice question that we're going to work on, and the practice question is: field experiments assess the impact of pollutants, conservation strategies, or climate interventions on the ecosystem. So we're going to write a program in Python to discuss this biodiversity issue. And before we write the program in Python, what we're going to do is we're going to import some Python libraries. And the first Python library that we're going to import is NumPy as NP, which is a numeric library that also creates NumPy arrays. And then we're going to import pandas as PD, which is a data processing library which creates data frames and series. And thirdly, we're going to import matplotlib.pyplot_splt, which is a visualization library. And from scipy.stats, we're going to import f_oneway. So scipy is Python's scientific library, and stats is a statistical module within scipy, and f_oneway is going to be the ANOVA function that we're going to use to perform a test. So the first thing that we do after we've imported our libraries is we want to set our seed. And the reason why you set your seed is because what happens when you set the seed, when you run the program, all the variables will be set up to the same values. And therefore, the program will run the same every time you run it. So that's why you want to set your seed. So we set our seed by typing np.random.seed, and you can put any number you want within the brackets. So we're going to define regions and intervention strategies. So regions is a list of region A, region B, and region C. And interventions is a list of pollutant reduction, habitat restoration, and control. So now what we're going to do is we're going to simulate biodiversity scores for each combination of region and intervention. So the first thing that we have is we have data, which is a variable that we've defined, which is an empty array. And for region and regions. And for intervention and interventions. If intervention is equal to pollution reduction, scores equals np.random.normal, bracket 75, 5, 30. So normal means you're creating a normal distribution. 75 is your mean, and 5 is your standard deviation, and 30 is your sample size. And then LF, intervention equals habitat restoration, scores equals np.random.normal, brackets 85, 5, 30. And that's an even higher biodiversity score. And else, this is control for no intervention. Scores equals np.random.normal, bracket 65, 5, 30. And so that's your lower biodiversity score. And then you're going to say for score and scores. Data.append, brackets, region, comma, intervention, comma, score. And so now what we're going to do is we're going to create a data frame that contains the data. So df equals pd.dataframe, brackets, data, comma, columns equals region, comma, intervention, comma, biodiversity. And so your column 0 is region, column 1 is intervention, and column 2 is biodiversity. And the reason why is because in Python, your number system starts with 0. And so now we're going to calculate the mean biodiversity score for each intervention. Summary equals df dot group by brackets, square brackets, region, comma, intervention, and then square brackets, biodiversity, comma, mean, comma, unstacked. So now we're going to print our summary statistics, and you're going to have mean biodiversity scores by region and intervention, and then we're going to print the summary. And now we're going to perform an ANOVA to assess the impact of the intervention strategies. So ANOVA results equals F underscore 118. And so the first one is DF, square brackets, DF intervention is equal to pollutant reduction, square brackets, biodiversity, comma. DF, square brackets, DF intervention is equal to habitat restoration, square brackets, biodiversity, comma. DF, square brackets, DF intervention is equal to controlled and square brackets, biodiversity. So now we're going to print the ANOVA results, and we're going to print the F statistic and the p-value. So we're going to come down here to the bottom of the cell, and you've got your values for control, habitat restoration, and pollution reduction column, intervention columns, and then regions for region A, B, and C. And then so that gives you the means for region A, B, and C and control, habitat restoration, and pollutant reduction. And then you've got your F statistic as 345.098 and your p-value, which is 0. And since the p-value is less than 0.05, that means you have to reject the null hypothesis and accept the alternate hypothesis. So the null hypothesis is going to be that the values, there's no significant difference between the values. And the alternate hypothesis is there is a significant difference between the values. So since the null hypothesis is being rejected, we have to accept that there is a significant difference between the values. So now what we're going to do is we're going to visualize the data using a bar chart of mean biodiversity scores. So plt.figure brackets fig size equals 6, 4, and summary.t.plot brackets kind equals bar, fig size equals 6, 4, alpha equals 0.8, color map equals viridis. And then we're going to customize the plot. So the title is Impact of Interventions on Biodiversity. The X label is Intervention Strategy. The Y label is Mean Biodiversity. The X sticks is a rotation of 45. You get a legend of a region, and the location is the upper left side. And your grid is axis equals Y, line style equals dash, alpha equals 0.7, plt.type layout, and plt.show. Okay, so now we have the impact of interventions on biodiversity. So you can see purple is region A, green is region B, and yellow is region C. So you can see we've got the control group, the habitat restoration group, and the pollutant reduction group. So you can see that the control group has the lowest means. The pollutant reduction group has the medium means, and the habitat restoration group has the highest means. So the habitat restoration group would be the one that they would select because it would give you the highest biodiversity score. But that concludes this video, In the next video, we will be covering some more statistical subjects. So I hope that you decide to watch the next one.